about some cheese sticks?
Yeah! What about some pizza?
Yeah!
Oh, true!
How about rainbow cupcakes?
To find the area of a pizza, we're going to use the shell method. The shell method basically takes an infinite number of hollow shells and uses the radius and the height of the function to find the volume, where p of x is going to be your function for the radius, and then your h of x is going to be the function for the height. We split the pizza into two sections, the crust and the flat part. We found that the height of the pizza until the base of the crust was 2 centimeters. So we used the shell method to find the volume of just the flat portion. So our p of x value would turn out to be our radius, which is 15, since it's 15 centimeters from the base. And then our h of x value, our height, would be 2 centimeters, since it's 2 centimeters off the ground. And our integral would be from 0 to 15, since it's from here to here. And when you solve that, you get 30x from 0 to 15. And then when you solve that, you get 900 pi centimeters cubed.
Okay, so first we modeled the crust using a quadratic equation, y equals negative 2/3 times x minus 13.5 squared plus 3.5. Then we found that the radius was x, so p of x equals x. And h of x just equals the function. Okay, from there we wrote down v equals 2 pi the integral from 12 to 15, so that we would only find the area where the crust was actually. Of p of x times h of x, which is up there, x times the function. Okay, after that we decided that we had to subtract 12 pi because there's an area underneath the y equals 2 of 6. And since we're revolving using shell, we have to multiply that by 2 pi, which turns it into 12 pi. Okay, from there, we anti-differentiated the equation and got 2 pi times negative 1/6 x to the 4th plus 6x cubed minus 59x squared. When we anti-differentiated, we got this equation. Once we plugged in the 15 and the 12, we got the answer as the volume equals 231 pi centimeters cubed. And that's the volume of the crust. So to find the overall volume of the pizza, we now have to add the volume of the crust to the volume of the bottom. So the total volume equals 1,131 pi centimeters cubed. Seems like quite a bit of pizza.
I'm Dustin.
And I'm Mike Z. And I know before dinner you get a little hungry, so I was gonna say, let's whip up some good old-fashioned cheese sticks. What do you say about that, Dustin King?
Sounds great.
Hey, I'm Dustin. And I'm Mike Z. And I know how you get those for-dinner jitters where you're just craving some food. So I say we whip up some old-fashioned epic cheese sticks.
But
How does that sound, Dustin King?
sounds great, but how do you know how much to have before dinner? So you don't get too full.
Well, I say we calculate this out real quick.
Good idea.
Alright.
So, after a series of very difficult calculations, we found that the equation of this graph, which is the side of the base of the cheese stick, is y equals negative 1.5 x squared plus 1.5. Alright, so to find the area of the cheese stick, what we're going to do is we're going to find the area of this face and multiply it by the length of the cheese stick, which is 11. So to find the area, we're going to take the integral of the equation. So it's going to be from negative 1 to 1, and the integral of that equation, negative 1.5 x squared plus 1.5 dx. Okay, so then we're going to integrate that. So the integration of that is
Negative 1/2 x cubed. That's a bad cube. Negative 1/2 x cubed plus 1.5 x. And we're going to have that solved from negative 1 to 1.
Alright, so we're going to take the integration of this equation, which is this area. Alright, and then we're going to plug in the numbers from top numbers and subtract it from the bottom one. Okay. Bracket. Got the bracket up here.
Bracket right there?
No, that's the bracket. Mike, just drop it. All that out. The top part is, what's the top part? 1. And then minus
And then you're subtracting a negative.
negative 1. So that equals 2. So the area of this is 2. Alright, so now we're going to solve this integration. So we're going to plug in the top number and subtract it from the bottom number.
These crappy markers.
It's crooked one.
That's okay. Here we go. And now that you have your equation, you anti-differentiated, you just plug in these two numbers right here, plug them into the equation, subtracting the b from the a. You plug in b, which is 1, then a, which is negative 1. Now you plug in your little numbers right there, and when you solve this one, you get 1, and you're subtracting a negative 1, which you get on the other side. So the area of this little shape right here is 2. And now that you found the area of this, we need to multiply that by 11, which is the length of our cheese stick, which simply comes out to 22. So the total volume of one of our cheese sticks is 22 centimeters cubed. Ta-da.
We solved that swifter than Sir Isaac Newton.
Now time to calculate your bundt cake. So the basic graph of a bundt cake is like this. The maximum is 9, and these two intersects are 5. So through finding the equation of the line, we found that the equation equaled negative 18 over 50 x squared plus 9. So that's your f of x. That's your height function when you're using the shell method. The x of it is equal to x plus 7, because it's rotated about this point. So when you plug that into your shell method, you get 2 pi, the integral you solve that whole thing through, you get 2 pi times 420. And in the end, you get 840 pi centimeters cubed for your bundt cake.
And now you can pass the test of BC Calc.
I'm Steven Johnson and I approve this message. I can give it. I'm Steven Johnson and I'm Steven Johnson and I approve this message. That's it. I think what else do you look at the camera? I'm Steven Johnson and I approve this message.
This whole meal is going to take about an hour to make. So these are some things you can do while you wait.
You can play some video games with Mr. Cohan.
You win again, Sir Cohan.
I always win.
You can lift weights. 2, 1. You can play soccer.
Oh!
You can do a push-up contest. You can educate a small child.
And that's where babies come from.